This is the second part of the review on Miracle causally aware imputation via learning missing data mechanisms. In this video, I will give a presentation about the experimental results that the authors provide, the reconstruction process that we went through, and also some related discussions. The authors provide experiment results on two types of data, synthetic and real. The synthetic data is generated from a known causal graph, and the real data are taken from the available UCI datasets. More precisely, the synthetic data used are generated with random Ernest-Reinai graphs with functional relationships from parent to children node, where each node has Gaussian noise of mean 0 and variance 1. And 10 different kinds of real UCI dataset are used, namely autism, life expectancy, energy, abalone, protein structure, communities and crime, yeast, mammographic masses, wine quality, and Facebook matrix. For baseline imputation, 6 different imputation methods are used, namely mean imputation, deep generative adversarial network using GAIN, K nearest neighbors, tree-based misforced, deep neural distribution matching based on optimal transport, and multivariate imputation by chained equations, which is also called the MICE. For the general setup of experiment, 30% of missingness was introduced to the data sets, and 80 to 20 train test split was used. Also, hyperparameter sweep, which is log-based, was conducted from e to the negative third to 100. Atom optimizer was used in the experiment with a learning rate of 0.0005 for up to maximum of 300 epochs. In order to create the missing data for MCAR, the authors randomly removed 30% of observations in each feature. For MAR, the authors sequentially defined the probability that the ith component of the nth sample is observed, conditioning on the missingness. For MNAR is also introduced by defining the probability as shown in the slide. After performing Miracle on baseline imputation, the results are evaluated based on 3 different criteria: missingness imputation performance, label prediction performance, and the congeniality. Missingness imputation performance is evaluated with the root mean squared error comparing the imputed missing values with the actual value. Label prediction performance is the ability to improve the post-imputation prediction, and for benchmark, support vector regression is used in all cases. The congeniality is the ability to impute values that respect the feature label relationship post-imputation. So root mean square error of support vector parameters learned from the complete dataset and imputed dataset are evaluated. And the figure shown is the result of Miracle on synthetic data in terms of RMSE. It shows that Miracle successfully refines all kinds of baseline imputation used with various dataset, data size, missingness ratio, and feature size on MAR and MNAR cases. And here's a more detailed results on MCAR case, which was not provided in the previous slide. As clearly shown, Miracle improves the baseline imputation method in all 3 evaluation criteria mentioned. For label prediction with varying missingness ratio, we can see that for some baseline imputation methods like MICE, KNN, and mean imputation, there is a notable improvement in prediction ability where missingness ratio of data is very high. For additional detailed results for MAR and MNAR cases, please refer to the appendix of the paper, and they show the similar trend to MCAR result. The results on real data set are shown in this slide. It shows improvement on all types of imputation as well. One thing to note is that the improvement is not outstanding in MCAR case compared to other cases, like MAR or MNAR. That makes sense because in MCAR cases, baseline imputation is already not biased. Another thing to note is that the result suggests Miracle never degrades baseline imputation. Though the improvement degree varies, Miracle shows some degrees of improvement on any dataset with any kind of baseline imputation. For label prediction and the congeniality evaluation, please refer to the appendix in the paper. And you can see three plots in this slide. The scatter plot on the left shows the relation between the improvement of Miracle and the number of causal parents. Here, we can see that when the DAG is sparse, which means that Miracle identifies fewer causal parents, the performance gain is greater. This result also aligns with the theory that graphs with less edges contain more information. When Miracle is less able to isolate causal parents, there are more spurious edges in the DAG, and thus the improvement is only marginal. The plot in the middle shows the convergence of Miracle on each baseline imputation with number of epochs. This graph not only shows that Miracle converges with different kinds of baseline imputations, but also that even starting with huge RMSE like mean imputation, Miracle always allows all imputation methods to converge to similar RMSE in the end. The last plot on the right shows the instance-wise refinement. All the points below the diagonal line represent improvement. And based on that, we can tell that Miracle brings improvement to all instances except those with very, very small errors. Also, even though Miracle does not provide improvement, it does not inflate the errors by a large margin in those cases. And additionally, we can conclude that Miracle improves imputation as training progresses by observing the slope of each line decreases with more epoch. And here we're going to talk about the reproduction process that we went through. For the reproduction process, we have attempted to reproduce the proposed results on synthetic data by tuning hyperparameters. We have performed log-based sweep for beta 1 and beta 2 from e to the -3 to 100, with mean and misforced baseline imputation on MCAR and MAR and MNAR settings, all three settings. Learning rate for all cases were set to 0.0005, as mentioned by the authors, data size 3000, number of steps 300, and feature size 10. For every 10 steps, imputed values were updated as the paper described. We have applied Miracle on top of mean imputation and misforced imputation, as they show the most difference in the result that the authors provided. Here is the full result of the hyperparameter tuning on MCAR, MAR, and MNAR. Interestingly, Miracle did not show significant improvement shown in the experimental result that the authors provide. With mean imputation as the baseline imputation, our results present only about 10% improved RMSE in all three missingness mechanisms, and less than 1 or 2% with misforced baseline imputation. Even though there was no major improvement, we concluded that the optimal values are 1 and 0.01 for beta 1 and beta 2 respectively for varying missing mechanism and baseline imputation. And here's a discussion on what would have caused the difference between our reproduction process and the author's experimental result. One of the possible reasons for such inconsistency can be due to tuning on hyperparameters other than beta 1 and beta 2. Though the paper suggests learning rate was set to 0.0005, which is also what we had set for our experiment, varying learning rate might provide better result. Also, another hyperparameter, lambda, which affects the weight in neural net exists, but is not specified by the authors. Thus, we set it to the default value in the given source code, but fine-tuning on lambda might also provide a better result. Another reason could be the difference in causal graph that we have generated data with. Like the graph that paper presents, our graph has 10 nodes or features, but has slightly different relations between the nodes. The graph on the top right corner is the DAG used by the authors to generate synthetic data. And the other one on the bottom right is the one that we used to generate synthetic data. Though it is not likely that there is an optimal graph for a miracle, such difference might result in disparity, we suspect. One last reason that we suspect is the process of generating MAR and MNAR. The source code provided by the authors does not provide means to generate MAR and MNAR mechanisms. Thus, we adopted open source for generating missing data. However, this reason is also not likely because Miracle showed consistent result with all three mechanisms on varying baseline imputation method. So this ends the review on Miracle, and thank you for watching.